Good morning to everybody, good afternoon, good evening, and thank you very much for joining us today, and welcome to this webinar from G3 PLC. My name is Leon Vergeer, and I'm the General Secretary of the G3 PLC Alliance. And also with us today is Mark Delandre, who is the chairman of the Alliance, and he can also answer any specific questions you may have today. Today we will talk about managing large smart metering systems running on G3 PLC. And today, millions of G3 PLC devices have successfully been deployed in many countries all over the world. But setting up and maintaining such large systems often is not well anticipated. DSOs tend to focus on the design of the system and rolling out the meters. And often they forget a little bit about the back office and the tools which are needed to maintain such a large scale system. So we are glad that we have today 3 experts from ENEDIS in France to share their experience on this topic. Nicolas Pigeon, Thibaut Mollier, and Rémi Dubal will give a presentation today about their G3 PLC system. So maybe you can very briefly introduce yourselves before we start. Nicolas, may I start with you, please?
Yes, hi everyone. My name is Nicolas Pigeon. I am a manager inside the Linky system team, and I am also dealing with the international smart metering projects at ENEDIS.
Thank you. Thibaut, maybe you can...
Yes, good morning, everyone. My name is Thibaut Mollier. I spent 4 years monitoring Linky in Paris and its areas. And I was the manager of the local supervision team. I now provide my expertise to many projects in ENEDIS.
Thank you.
Hello, everybody. Rémi Dubal. I'm G3 PLC expert at ENEDIS laboratory from 4 years. And I work on G3 PLC studies and optimization for Linky.
Okay, thank you very much. So I think we have the right people in the call, in the webinar today to inform us about managing G3 PLC networks. So before we move to the ENEDIS presentation, I would like to give a short update about G3 PLC, as many of the people who are in the call today are not member of the G3 PLC Alliance, so they may not be aware of the latest developments regarding G3 PLC. And after the presentation from ENEDIS, there should be enough time to have a discussion and answer all your questions. So if you have any questions, please do let us know by using the Ask a Question to Staff box on the right side of your screen. We will try to answer as many questions as we can in the webinar. And if we can't answer it during the webinar, we will follow up with you afterwards. And also, after the webinar, we will share the presentations with all of you. So let me start with giving you a short update on G3 PLC and the G3 PLC Alliance. G3 PLC is a proven power line communication technology offering lowest total cost of ownership and independency on telcos. G3 PLC is a very cost-effective solution because DSOs use their own infrastructure for communication. The total cost of ownership is low as there is no need to install any wires. The cost of the meters is lower because the bill of material of the smart meters is lower, and communication costs itself are also lower as there are no telecommunication fees to be paid to commercial telco operators. And another advantage of power line communication is that because utilities use their own network for the communications, they are not dependent on commercial telco operators, which have their own development cycles with their own timelines. On the right side of the screen, you see a couple of application areas for G3 PLC. As you probably know, G3 PLC was developed for the mass rollout of smart meters. And the main application still is in smart metering. But G3 PLC by now is being used in many other applications, such as street lighting, EV charging systems, home automation, and for example, also in railway solutions, in smart railways. And we will be talking a lot later on in this presentation about G3 PLC and smart metering. So just to illustrate one of the other use cases for G3 PLC, I included one slide about G3 PLC application in railways. And this slide shows, for example, in Italy, G3 PLC is being used for the monitoring and controlling of lighting systems in railway systems. It's being used to control the heating of switches in the railway track to prevent them from freezing in the winter. And it's also being used to control safety lightings in tunnel. And in Italy, G3 PLC is a standard required by the Italian railway infrastructure company. And we have several members in our alliance from Italy working on these type of applications of G3 PLC. And another example is Panasonic. Panasonic is also a member of the G3 PLC alliance, active in this field. And they are using G3 PLC to control the lighting of railway platforms in several stations in Tokyo. So this is an example of one of the other application areas for G3 PLC. Back to G3 PLC technology, G3 PLC embeds all the modern features for a long-term network operation, and it was designed for harsh network conditions. It's a very robust technology. It operates at low signal-to-noise ratios. It works with different modulations depending on the conditions in the network. And it is self-healing, meaning that when there is a breakup or a change in the infrastructure of the system and the communication line is broken, then the nodes in the system will automatically identify this and will find a new optimal route for the communication. So it will self-heal the communication network without any interference from outside. G3 PLC communication can easily cover several hundreds of meters, and we even know about examples of kilometers covered by G3 PLC communication. It supports high data rates. It has embedded state-of-the-art security in the protocol. It supports end-to-end IP communication. It is IPv6 compliant, and also important, G3 PLC is an open international standard recognized by the International ITU organization. It's a mature technology. We now have over 50 million G3 PLC products in operation in more than 30 countries all over the world. PLC is the most widely used communication technology for smart metering in Europe, as you probably know. But G3 PLC is not only being used in Europe. There are many implementations in Asia, in Africa, in South America, in the Middle East. So it's widely used globally. And G3 PLC is supported by an international group of more than 90 DSOs, utilities, and industrial players who all invest in the success of G3 PLC now and also for the success in the future. And all these companies together, they form the G3 PLC Alliance, which is a not-for-profit organization. And the main tasks of the Alliance are to maintain and enhance the specification, to promote G3 PLC worldwide, and to operate a certification program so we can guarantee that the products from different manufacturers are interoperable between each other. And the last slide about G3 PLC before we move to the ENEDIS presentation is about the latest development regarding G3 PLC. In addition to the existing PLC profiles we have introduced this year an extended profile with radio capabilities, the G3 PLC hybrid solution. And with the hybrid solution, each device in the network can use PLC for the communication, but it can also use RF. And depending on the actual conditions in the field, the messages between two devices will be sent over the best available channel for the communication. So it combines the strength of both PLC and RF communication, and that's why we call it the next generation in PLC technology. RF is being used as a complementary technology in the communication, and this way the hybrid solution can maximize the coverage and the connectivity and can provide an even better, more efficient and more cost-effective solution for smart grids, for smart cities, for industrial applications. And above that, it also opens up new use cases for G3 PLC because it extends the connectivity to RF-only devices. So like I said, we introduced this hybrid profile this year. The specification for the hybrid is ready, it's been finalized. The first field results from harsh grids are very positive, and we are now finalizing the certification tests, and the certification for our hybrid solution will open later in this year. Well, this webinar is not about the hybrid solution, but if you want to know more about the hybrid solution, please check on our website. There are different presentations, field experiences you can find there, or contact one of our members or ask me, and I will explain further about the hybrid solution we developed. So G3 PLC is a very powerful communication backbone for the smart grid. I hope I explained. And after this introduction about G3 PLC, I'd like to hand over to ENEDIS to share their experience on managing G3 PLC networks.
Okay, so let's start with a few words about us. ENEDIS is a French company that manages the electricity distribution network. This is the largest DSO in France with 38,000 employees and around 14 billion euro revenue. ENEDIS is a subsidiary of the EDF group and operates 95% of the French distribution network. So ENEDIS is only managing the distribution, production and transportation in France are done by other companies. Inside ENEDIS, Linky is the smart metering program. This is a large-scale rollout of 35 million smart meters using PLC G3 communication technology. The rollout started in 2015 and should finish in 2021 as planned. As of today, 28 million meters have already been installed at the end of last week, and 86% of the concentrators also. We just wanted to highlight that for a massive rollout of PLC G3 smart meters, ENEDIS adopted a leopard pattern strategy. It means that first we install the concentrator, and then we install the meters quickly on that area to have a good saturation level and to have a good communication performance. Also, before rolling out, there is no need to have specific noise measurement or network engineering with PLC G3. It's useless, so it is quite plug and play, in fact. And what we see is that PLC troubleshooting is usually the last thing to do to make the system work. There are many other things to check before. So here you have an overview of the Linky AMI. So on the left side, you have the meters, G3 PLC meters. Then you have the G3 PLC network. You have the DCUs that are used to collect the meters, the GPRS communication between the DCU and the system, and finally a bunch of information systems to manage everything. Each component of this infrastructure needs monitoring and maintenance to reach performance levels required by the French regulator. In France, we are required to have at least 98% of daily collection rate, and this is a percent that is really end-to-end, so from the meters to the information system. And depending on the performance level you need to reach, a dedicated system may be needed to monitor the entire infrastructure. This is the case in France. In fact, we need a complete communication and monitoring chain to have good performance. So from our experience, to keep an AMI up and running, you need 3 items. The first one is monitoring. It can be a whole network supervision entity with people, tools, and processes, but it can also be lighter. The target here is to have an accurate monitoring of the services and all the technical components of the AMI. Then you also need on-field intervention, because at some point you will need to get your hands dirty. Interventions can be prepared to be as quick and efficient as possible, and technicians will make field measurements with appropriate tools and take adequate actions. And finally, you need expertise and knowledge management. You need to feedback a loop with what was observed on the field to a team of experts who ensure level 2 support. Feedback is used to help improve knowledge, such as possible PLC perturbations and disturbances. You need to improve processes, such as the automated remote troubleshooting system that we can have in France, and also training programs.
Okay, so our first step in PLC troubleshooting and for many other issues is to monitor and analyze remotely our AMI networks. This photo is one of the local supervisors who use our Linky supervision system and try to match information with our GIS. I want to show you today how we are organized and face the communication issues, and especially PLC issues when we meet them. First, we need to understand that what we are monitoring and for what. In one hand, we have a technical architecture that Nicolas just explained to you. This system can send alarms and many data that we treat as soon as possible. For example, if a DCU sends an electrical failure and stops collecting, we are going to send a tech before a remote operation is asked or before a customer claim. In the other end, we check that all our services like data collection, lockers, remote operations are well done on a daily basis. This is like a mirror for the health of the AMI system. So now, how do we do? I want to show you the three-level organization of ENEDIS. As you know, France is a quite big territory. We need a global monitoring, but we also need people who are close to the field. That's why we decided to split the responsibilities. The Hypervision Control Center manages the global performance of the IMI and leads the supervision centers. They have administrator rights and can upload parameters and new updates, for example, firmware or DCU software. They ensure the national consistency and they treat large-scale incidents. For example, they can be in touch with a mobile network operator during an incident. The local supervision center manage activities linked with the IMI maintenance. There are 8, as you can see on the map. They solve cases individually. They are in touch with activity planners and manage the workflow of IMI maintenance. They are in charge of PLC troubleshooting. And the regional level actors plan and realize the maintenance. They take care of the customer and supplier services and guarantee the database accuracy. On each region, there is one or more technicians trained to PLC troubleshooting, and we will focus on them later. It's important to understand that this organization was made during a rollout phase, so we decided to not clean the network before that. This is a tool called LinkySup. LinkySup detects incidents and automatically run actions with low added values. For example, firmware updates, reboots, method kicks. Thanks to that, all the rules are designed with Hypervision Control Center, and most of the cases are closed without any human actions. The objective is to provide the supervisions all the information to investigate, and for example, the cartography and customer services, customer address, etc. From the software, we can send the case to the good service, depending on the situation. It can be PLC troubleshooting, but also hardware maintenance, etc. So now on field interventions. The first step is to go on the field and to solve the issue. What we do is we train people for PLC troubleshooting. We have around 60 local technicians on each regional office. They work part-time on this PLC activity. It's important to say that because it's not enough to work with them on a daily basis. So they work between 1 or 2 days a month on this activity. It's a good career opportunity for them. They need to be specialists. They are not telco specialists, but they need to have a good experience in ENEDIS, in customer services. They need to be curious, and they need to want to solve issues. They have a training of 2 or 3 days. It's an in-house training, and also they practice in experimental network. The training is 3 days, and we started this activity in 2016. One of the feedback is that we don't need to start too early. You need to have few meters installed in the field because if the technician don't practice, he will lose the skills he learned in the training. To go on the field, they have a suitcase and a tablet. It allows a safe connection to the network. The tablet has a software called Expresso. It can collect measurements. It can give access to context information to the technician, history, communication stats, device connected to the DCU, etc. They can do actions with this tablet. For example, a reboot, a reboot plan, a test, etc. And it ensures traceability of the measurements, the actions, the comments, and it goes back to the supervision when the case is closed.
All right, so this tool case has been designed for ENEDIS in order to make field intervention easier and safer, but it's mainly equipped with two tools that are available on the market and that you will need for on-field intervention. So the first one is an oscilloscope. Oscilloscope is used to make instantaneous measures on the field. So it shows you what we call frequency spectrum. It's useful to see noises on the network to detect and locate them. And the second tool is the PLC sniffer, and it is used the Neuron Nbox tool, a device made by Neuron. It's more useful for long-term measures on the field. It shows G3 PLC traffic on the network. It helps you to understand the traffic for in-depth analysis and studies on application. It also shows some statistics about bandwidth occupation and link quality between the nodes. To use these tools, you will need a smartphone, PC, or tablet to be used with appropriate softwares. All right, let's talk now about expertise and knowledge management, which is more my work because I work on a national team at ENEDIS laboratory. So here are the topics that you will need to focus to develop your expertise. At ENEDIS, they are managed by a national team in Paris. We use field feedbacks to design and provide improvements. So the first topic is the device performances that are impacted by the noise and their own performances. Secondly, the parameters that depends on your use case and sometimes your network, electric network. Third one is the service that you want to perform, that you need to perform on the system, such as grid services, for example. Then we help developers to automate some detection analysis on Linky Sub. And finally, we use feedbacks to improve the training of the technician through the feedbacks. So now let's focus on the first two topics, the device performances and the parameters. So first of all, at ENEDIS, before the rollout, we really focused on the device performances. It's really important because it will give you an easier rollout because the device will be immune to the noises and have better transmission capacity. So as you may know, G3 PLC Alliance provides a certification program that tests the performance of the devices, minimal performance of the devices. And at ENEDIS, we add to these tests some more tests with on-field constraints, such as noise, reproduction of low impedance, and medium variation. It's important to have tests that include the constraint of your real electrical networks. We also have a performance lab with a 3-phase and multiple feeders. And finally, we use an experimental network for issue analysis, and because it allows full feature tests and interoperability condition in real network. The second topic is the parameters. In G3 PLC protocol, you have a lot of parameters that will affect your system performance. So the main recommendation is to have a global default parameters for your meters and DCU. The document published by the G3 PLC Alliance, called G3 PLC User Guidelines, helps you to define your parameters according to your use case. You need to work on that before the rollout in order to implement these parameters during the production of the devices or the rollout through mobility devices. And then some specific cases might require parameter tuning. And in order to do that, you need to have your parameter remotely accessible through your HES. We will see that during the case studies.
Okay, so now I want to show you a few cases that happened on the field. And I will start with the first one, which was in Évry. It's a city near Paris. We detected 7 DCU with very, very low performances, even though the saturation was very good. All the substations were located at the same district, and each cluster was at between 100 and 250 meters. All the DCUs were reachable, connected, they sent messages, but the communication was was close to zero. So we investigated with the supervision team. Oh, sorry. So in this city, you will find a lot of building bars from the 70s and 80s. The density is quite high, as you can see on the cartography of the first substation. So when we checked the customers, we found a boiler room, and it was our main hypothesis. So we went on the field with the team and all the tools. First, we made the measurements close to the DCU to capture the noise signature. As you can see, the noise is quite powerful, and the DCU was not able to communicate in PLC. We made the same measurements close to the suspected origin of the noise. As you can see, the noise gets more powerful close to the boiler room. You don't see it, but we made many measurements to check that. And so we called the company to get an appointment with a technician. The last things to do is to confirm the hypothesis. And for that, we disconnected briefly the boiler room. And so the noise disappeared. After a few discussions, we found out that the boiler company disconnected all the low-pass filters behind the frequency variator. So after reconnecting all the filters, the performances went up, and so we closed the case. So this is the first example of what you can face on the field. But with that, we saw this with the supervision tool, and so the next case was from a customer claim. It's a Parisian who called us because they still doesn't have these services after a few months after the installation of the meter. The DCU data collection rate was around 34%, so it didn't show up in the supervision tool. That's why we didn't see it, but the prioritization became high when the customer called us. This is a prioritization because of the customer claim. So the area is a new neighbor in Paris, close to a brand new subway station. As you can see, the buildings are modern and they all have solar panels. We saw that the saturation ratio was not good enough in some areas. That means that the PLC network may not be strong enough to face a noise. So we did the same protocol as Évry. We went to the substation to check that everything was fine with the DCU. We thought that the noise looked like an inverter noise from a solar panel. So we confirmed that with the second measurements in the elementary school equipped with the solar panels. The last measure was to go on the customer building located on the other feeder. And so we saw that the noise was still there, but not powerful enough to avoid the loss of communication. That means that we always have we don't always have to remove the nodes to solve a case. It's very important to say that. So what we did is we installed a new Linky meter at the ground floor of the building. And so with that, we improved the saturation ratio locally to make the PLC network more efficient. And so the day after the installation, as you can see, we had an improvement of 41 points of the daily data collection rates. It was still not perfect, but we asked to put more meters on the building to improve the performances again.
All right, for the third use case, let's focus on a network with 800 meters. Back in the time, that was the biggest network we had deployed, fully deployed on our system. So this network had really bad performances, even if it was fully deployed and all the meters were installed. So in order to improve the performances, we firstly put a G3 PLC analyzer near the DC station, the DCU, near the DCU, to have good knowledge of what happened on the network. Then we also perform a DCU log analysis. And with the collective work with the technicians, the supervision, hypervision, and the G3 PLC expert with our tools, we developed and proposed some software optimization and parameters modification to have better performances. So the performance went up from 20% data collection rate to 90% data collection rate. So this is why it is important to have remote access to your parameters, because in this kind of cases, it's because we have access to the meters and DCU parameters in our ITS that we can have performance improvement.
So to sum up, maintenance and troubleshooting are vital to maintain equipment and infrastructures up and running and ensure services are delivered. G3 PLC, as any communication system, is no exception to that. Monitoring is essential to detect loss of performances, both technical performances and service performances. You need to listen to your client, and you need to analyze before sending technical teams on the field in order to make their intervention easier. On-field interventions fuel a feedback loop to improve knowledge, training, and so on, and make future incident resolution easier. Troubleshooting can be easy, and some actions can be automated. As Thibaut said, there are automated reboots, upgrades, kicks, and so on. So you need to let your teams focus on trickier situations. And finally, we haven't mentioned it so far, but troubleshooting can be outsourced. Although this is not how ENEDIS is managing it right now, it is also reversible. For example, in India, EDF is ensuring maintenance for 7 years of a smart metering system, and the target is to hand it back to the customer, to ESL, after 7 years of maintenance from us. So that's all for us. If you have any questions, we are ready.
Okay, thank you very much for your interesting presentation, guys. So I'm looking at a couple of the questions. Let me see. So if you have any questions, please send them in on the using the question box on the right side of your screen. Um,
Non, moi je redis.
Non, parce que c'est l'ordinateur qui.
Non, j'en veux une.
Moi j'en ai deux, mais c'est sur le Android à chaque fois.
I'm trying. I put some questions on the screen, but I'm trying to get them to share them. Okay, I'm getting quite some questions right now. One of the questions is, Nicola, maybe you can answer that one. How does meter data management software work with PLC? And can you give examples of it in operation?
Yes, so in fact, MDM is not the trickiest part in this kind of system. MDM, in fact, is only to manage business objects. So the trickiest part is the HES, which is managing the communication with the meters and the DCUs. So for G3 PLC, there are many HES that are already compatible with this technology. The one we are building ourselves, the Linky one, is an example, but there are at least 3 or 4 solutions that we know. So it's difficult to recommend right now HES because it really depends on what you want to do with it. But be sure that there is no big issue with that, and mostly any HES manufacturer are already offering something for G3 PLC.
Okay, thank you. Thank you. I hope that answers. And another quite technical question, I think, is about crosstalk. How to solve the problem of signal crosstalk at the end of a line of 2 adjacent transformers. Maybe Remy, that's something you can shine a light on.
Yeah, well, on this topic, in our point of view, the signal crosstalk is not a problem because the system adapts to the meter choice, actually. If a meter wants to connect to DCU rather than another one, it will be connected as always. So this is not a problem, and even if it's this adaptation is a solution when you have operation on your electrical network that meters need to be connected by another DCU.
So you're saying actually it's not a problem in practice if you have crosstalk.
Mm-hmm. But your system needs to support it. Your HES and DCU need to support it.
Okay, thank you, Remy. Another interesting question posed is about the back office required. Can you say anything about the average number of people you would need in the back office and in the field, maybe, for example, for 10,000 smart meters?
Yeah, I can answer that. It's a very interesting question because the maintenance team in ENEDIS is integrated in the technician fleet of ENEDIS. So with remote operations, we save time for this maintenance. So we didn't improve or we don't have more technicians for this maintenance. And for the supervision, I think you don't need to check only the number of meters, but also the numbers of DCU that you will monitor. I can't give you a precise number because it will depend on the tools that you provide, the objectives that you have, and also the performance of the IMI system and the meters and the DCU. So we mainly face hardware issues, software issues, PLC maintenance is not the main activity of supervision. It's only a small part, but sometimes some cases can be time they can take time. But that's why I don't give you an average number. Maybe I can say in my team we were 5 people, but for a goal of 6 million, between 6 and 5 million meters. So it's a quite small team for a large number of meters. That's the only number I can give you.
Yeah. Yeah, thank you. Yeah, it's good. It's good to remember that you are actually still middle in the rollout of the G3 PLC meters, and that the organization you described is currently managing, I think, about 27 million smart meters already.
And this organization is not fixed in the time; it can change. And you can adapt the organization depending on the number of cases you have in the time.
All right, thank you very much, Thibaut. Let's see. Another question. Also quite technical question, I think. What kind of issues do you expect, or what advice can you give when you have multiple data concentrators on the same low voltage network?
Okay, yeah. So the main issue is, of course, that your DCU cannot be synchronized. The G3 PLC network doesn't synchronize the two DCU on one network. So so there might be conflicts when of bandwidth use. Sorry. So the main advice, if you really want to put multiple DCU in one LV network, is to really put them at different places, not collocate or not near each other, because they might lead to bandwidth conflicts.
Okay, I hope that answers the question. Otherwise, please let me know on the question box. I'm looking at the questions. Another one we already got. I think this one we got before the webinar. Are you in ENEDIS using any software planning tools to predict upfront network KPIs and the equipment location? I think they mean the location you would need for the equipment.
So the brief answer is no. We don't use planning tools to know where we are putting devices, where we should put devices on the network. We are just using planning tools to roll out. So just to organize our team to install meters on the field. But we are not using anything before going on the field, putting the meters, because this is useless. As I said before, it's quite plug and play. So the PLC issues that we can find are quite not often. It's really rare, in fact. So we don't need to plan anything, and it costs much less to go on the field after we deploy to solve some issues one by one than having everything planned before. It is not needed, so we don't use it.
Okay, a related question to this is how do you plan the locations of the DCUs in the rollout?
In fact, the DCU, it's one DCU per substation. So it's quite. There is no engineering rule about this. It's a fixed place. It's in the substation, and 1 meter per house per apartment. So there is no need to put other meters somewhere else on the network or other DCUs. We are not facing this kind of issues.
No, so we understand the rollout is quite simple in that respect. You just position. I think you start with positioning the DCU, the data concentrators.
Yeah.
And following that, you just install the meters, replace the existing meters.
Exactly, and that's it. It works.
That's it. Well, that's good to hear from you. Then there was a question about data collection. Remy, maybe you can help with that. The daily collection rate is based on load profile of 15 minutes, or is it daily consumption data that you collect?
Well, actually, the collection of our images is only daily basis, on only all 24 hours, but we collect some data that that describe the load curve at 1 hour step.
But you collect
Daily basis only.
daily. You collect the 12 or the 15-minute data, I believe.
Yeah, but not on all the meters.
On some meters.
Yes, the performance we gave is only for daily indexes, energy indexes, and load profiles are only collected for customers that need it, so not everybody. And we cannot go to 15 minutes. We are not allowed to. The minimum is 30 minutes in France, because otherwise there are privacy issues.
Okay, yeah. So we have quite a number of questions coming in. So I don't think we will be able to answer all questions, but if we can't answer your question, then we will come back to it after the webinar directly to you. But I got 2 questions, interesting questions about performance, Remy. Maybe you can help with that. It's especially about the parameters and the used and the default parameters being used. So how many deployed meters use default parameters? And can you tell a little bit about what parameters you may change to improve performance in the field?
Right. So here at ENEDIS, we have a parameter set that is different from the G3 PLC specification default parameters. We defined from our first pilots in G3 PLC. So all our meters are based on our default parameter set, but there is some specific cases that, for example, the network with 800 meters that I present you, that have some specific parameters, such as the route validity timing that is different, and some applicative parameters. So what we call the delay before deconnection, basically. All the meters disconnect after 24 hours of inactivity in case they lost the connection with their DCU to find another network. So we put it from 24 hours in default parameters to 48 hours in this specific case. To avoid to lost and reconnect network each day, each day. So these are the main 2 differences that we made on this network.
And in that respect, it's also good to mention maybe that the technical group in the Alliance has been working on guidelines.
Yeah. So these guidelines have been fed with ENEDIS feedback with the Linky rollout. I participate to the redaction of this document, and you will find in it some feedback from us.
Yeah, and some of these guidelines are available on the website for everybody, and some are available to members of the Alliance. But please, if you want to know about technical details of G3 PLC, please do check on our website, because there are some interesting guidelines, I think, available for anybody interested in G3 PLC. Another question, we get many questions on quite technical questions, I think. Nicolas, maybe you can say something about this one. How is the experience in ENEDIS on communication errors on a very clean network? Is that
yes, on a clean network, basically, I look at Remy because he's more experienced than I am, but there are no communication issues. It's quite clean, so no problem. In fact, we have a lab that Remy told about before. This lab, we can choose the disturbances that we put on the test platform. When there are no disturbances, it's quite fast and quite clean, I think. Yeah, there are no reason that we should have some communication errors.
Yeah.
You explained how you've shown us the tool, the tools you use for the field analysis, and in that box there was a Neuron NBox tool. Can you explain a little bit more about how that tool is being used by ENEDIS?
Yeah. So ENEDIS used the one-phase NBox tool that was previously made by Neuron, but today they are making a three-phase case with an NBox tool inside. But this is quite the same product actually. So they are used by the technician to have some statistics about the network, to qualify the quality, the link quality between the nodes, and to have a first overview of the network. And they are used by the PLC experts that can receive from the technician the G3 PLC network traffic captures that can be sent and received between the services here at ENEDIS. They might be used as a noise measure tool, but they cannot allow you to detect and find a noise in your network. That is more the role of the picoscope.
Yeah, and this NBox tool is being used by the field technicians in the field.
Yeah, well, they are used by the field technician mainly for the expertise activity, because they capture and they send to the experts the network traffic analysis.
Okay. I'm looking at the time, and I see that actually we've already run out of the time we reserved for the webinar. There were quite a number of questions we still can answer, but I think I'll work with the people from ENEDIS to answer them directly after the webinar and let you know all about that. But one final question maybe to answer, maybe Nicolas, you can help us with that. Is there a maximum number of meters per data concentrator for optimum operation?
In France, it's 1200. In fact, the biggest cluster we have is 1200, and so we know the system is up and running until that limit. So this is the max we have, but it's only 2 or 3 stations in France. Most stations are less than 300 or 400, I think.
Yeah. Well, that's the maximum number within ENEDIS. There is no theoretical or practical maximum from the protocol perspective, I believe.
Well, it's more than 65K, I think.
Yeah, right.
But it's half. Okay. Remy just told me that it's 32K, 32,000.
30,000. The theoretical limit from the G3 specification.
Okay, well, like I said, we have to stop here because of the time, but we will answer the questions which are still open, and we will also share with you the presentation from today. So I want to thank you very much, Nicolas, Thibaut, and Remy, for sharing all your insights today. I think it's really, really useful for people working with G3 PLC networks. Mark, is there anything you want to add before we close? Is there anything you wanted to address?
No, I would like to thank everybody, and especially you, Leon, and the team from ENEDIS. What I can say, we have today in the field 28 million PLC meters. They work perfectly fine, and the team to operate this huge number of meters in the field is very, very small. So we cannot say it's a 1 for 10K meter, because it's probably only 1 per million meter in the field. It's an automatic system. It works perfectly fine, and every day we add in the field 20,000 meters. The end of the rollout is planned for the end of 2021, and France will be probably the first country with a huge number of PLC meters in the field, excepted China for sure. So once again, thanks a lot everybody, and we'll try to answer together to all the questions.
Yeah, thank you very much, and hope to talk to you again some other time soon. Thank you and bye-bye.
Thank you.
Bye, everybody.
Thank you.